So as I was saying before, I'm Kyle Simpson. I'm a JavaScript architect. I do a lot of web performance optimization, things of that nature. We're going to be talking today about HTML5 and JavaScript, and I'm going to call those HTML5 and friends because I actually don't really care what label you put on it or what spec it's in. The point is that HTML5 is sort of ushered in this open thing. I have a book that has several chapters about things that we're talking about today. This talk goes more in depth from what the book is, but if you want to go and reference that, AuthD is a discount code. It'll get you 50% off of that book. So if you're interested, go grab that. All right, today the talk that I'm going to give is about building a game. This is not a talk about game mechanics or anything like that. We're going to focus on the raw underlying HTML5 JavaScript APIs that I weave together. I was tired, even in the book, I was tired of having each of these different APIs represented by these small little toy examples, and I wanted one coherent application that I could build from scratch and weave in all these different advanced APIs together. And this game is what I came up with. So it is not, like I said, it's not a talk about how great my game mechanics are. But this game's called We Puzzle It. It is a multiplayer online puzzle solving game. You upload images, it slices them up into tiles, and then you compete and cooperate with each other to get the tiles in the right spot to solve the jigsaw puzzle. Get points for how quickly you do so. And so we will, later on, you'll be able to see that, and hopefully, if the Wi-Fi holds up, we'll be able to play it. All the code that I'm talking about today is up on GitHub. Again, all you need is the orange part. But if you just go to GitHub and search for Getify, you'll be able to find the We Puzzle It game. All right, so the first part of this talk, we're going to talk about some of the lower level, simpler APIs, and these are the gateway drugs that I want to get you hooked on HTML5, JavaScript, get you kind of addicted by the end of this talk. So the first things that we'll talk about: local storage, session storage, history, app cache, and canvas. All right, so local storage and session storage persist data inside of the user's web browser better than, say, cookies do, because it gives you a dedicated location, usually about 5 megabytes per website. Gives you a dedicated location to store key value pairs of data, similar to how you might do it in a NoSQL database or something like that. So you can see here, we have very simple API, and it's the same for both session storage and for local storage. It's get item to grab it out by its key, set item to put it in by its key, remove item to delete it. It's pretty straightforward. I use this in the application to do some very simple things like persisting on the login form, which you'll see later. When you see the login form and you see a place for a name and an email, I use the local storage to remember that after the first time you've typed that in, so you don't have to keep retyping that in. And I use the session storage to preserve the connection information so that I can reestablish the socket if you refresh the page or something of that nature. So session storage, like it says, it's dealing with the session that's happening inside the browser tab. Local storage will last for much, much longer. You do want to be careful with something like local storage, because if you start storing a bunch of data there and you never clean up after yourselves and the user isn't cleaning up, you can actually pollute a lot of data into their system. Some browsers don't clean out local storage the same way that they clean out temporary internet files. So be careful with that. But as you can see, it's pretty straightforward. On line 37, I use json.stringify because I'm pushing in string values. So local storage and session storage stores string values, but you can do structured by JSON serialization. Next, let's talk about the history API. How many of you have been familiar with or pissed off about those hashbang URLs, the ones like Twitter has and so forth? Okay, yeah, hashbang URLs, kind of the bane of our existence. They were invented as a hack to solve the problem that for years, and like a decade or more, we didn't have what we actually needed by way of JavaScript's ability to manage the history queue of your browser, the backward and forward queue. We didn't have what we needed, and so we invented all these ridiculous hacks to get around those problems. In particular, what we wanted is to be able to change the URL of the browser so that there was some sort of state preservation in the address bar, but we didn't want that to cause a whole new page refresh. The awesome part is that HTML5 came along and said, let's go ahead and pave that Conf path. Let's go ahead and give them that functionality they've been needing, and let's do so in a structured way. So we have a set of extensions to our existing history capability. There is a wrapper called history.js. I highly recommend using polyfills and other things like that when you can. History.js is awesome because it does fall back to the old behavior in older browsers for you, so you don't have to think about it. But you can see on line 38, I'm using there, I'm binding, I'm listening for the state change. That tells me when the user clicks the backward and forward button. When they do that, I get a state change, and that allows me to respond and load up the contents of the page in my single page app the way I would want to. And then you can see here, replace state and push state. That's how we manage that queue. So replace state does what it sounds, takes the existing entry in the address bar, the existing entry in the address bar as well as in the backward-forward queue. It takes that existing entry and overwrites it. So I use this in the login page, for instance. The login page of the app, once you have logged in, there's no reason for that login page to be in your backward-forward cache, because you're never going to want to go back to that login page just to be redirected. So after you're done with the login page, the next page you go to, I go ahead and replace that with the new page that you've gone to, thereby removing login from the queue. Push state, on the other hand, pushes it in, creates a new entry, and that creates a navigable. And as you see, if you play around the game later, you'll see how it's a single page app, but it does actually manage the address bar with index.html and other types of, exactly like you would expect, but it's not making full page requests. The reason I do that is because there's a socket connection for this game, and I don't want to reestablish that socket unnecessarily every page load, so we use a single page application concept, and we use History API to manage it a lot better. Next, we'll talk about app cache. I'm not a huge fan of app cache, and there's actually a talk that was just recently given. You should definitely go look up app cache douchebag. It's an awesome talk. Go and Google that. Basically, app cache has a lot of problems. It has a lot of promise, and it has a lot of problems. And I do not use this. You can see in my little to-do note, I do not use this yet in the application because I'm still under development. I would highly suggest that you not use app cache until your application is basically done, because it's a real pain in the butt to deal with clearing out that app cache or always updating a file. I'm not going to spend a whole lot of time talking about all the problems of app cache, but I will talk about the JavaScript API that it gives us that helps smooth out some of those problems. So the main concern that we have is that when an application is app cached, it's really persistently cached, and even if you update the files, a user doesn't necessarily get notified, and even on a refresh, they don't get those files. And even if you take the extra step of updating your manifest file, which is what you have to do to notify the browser, now it takes 2 page refreshes before the user actually gets those files. So like I said, it's really, really persistent caching for the offline use cases and so forth. So the JavaScript API helps us deal with that a little bit. Inside of the running of the page, and I might hook this up on an interval in my application, or you may have it as an on-demand button, but inside, I can tell the browser, go and ask if the manifest file is updated. And if it has been updated, go ahead and fetch all those contents in the background. And then I can listen for when that update finishes, and I can prompt the user and say, hey, there's new files. Would you like to go ahead and refresh so we get those new files? So that smooths things out to 1 page refresh instead of the ugly 2 that users normally have to do. Canvas. This is a screenshot of a part of the game, and what I want you to notice, it's maybe hard to see for some of you in the back, but what I want you to notice is the slight grid effect that I have overlaid on top of this image, this creepy clown that I've uploaded. I have a difficulty selector down at the bottom, and so if you select hard, it makes smaller tiles and more of them. But I wanted an effect to overlay the grid on top of the image to show you where those slices are going to be made, but I didn't want to do so in sort of the ugly way of just drawing lines. And Canvas gave us a couple of interesting advanced features to allow us to accomplish that. So we'll take a look at that code. The first thing is that I can take an image inside of an image element, or, well, basically inside of an image element, or a canvas element, or a video element, but I can draw that image into a canvas using the draw image command. And it has a variety of different ways that the parameters can be used. But if you take a look at the specification for it, you can see it's pretty straightforward what these parameters are: the original XY width and height, and then the new XY width and height. That's what that boils down to. But we draw from an image element into the canvas, and then I get the image data back out of the canvas as a data URL. What's awesome about this is I've used the canvas's power of its resampling and resizing and cropping off of my image so that I have it in a whatever image you've uploaded, I've got a predictable image ratio, if you will, and now I've got it right back inside of an image tag as a data URL without any transfer over to the server and asking it to do it with PHP or anything like that. It's happened right inside the browser with 2 commands: draw image and toData URL. And I find in the work that I do with Canvas, I do this a lot. I trade back and forth between images and canvases back and forth, and it's incredibly fast, very efficient, and these two functions make it very easy to do. The next thing is I wanted to, so now that I've got a predictable image, now I want to be able to draw that grid. So the first thing is I can't actually use lines because I'm going to use clipping masks, and in Canvas, unfortunately, a line can't participate in a clipping mask. But if I do a rectangle that's the shape of a line, just 2 pixels wide, then it will participate in a clipping mask. You can see I don't have an arrow to it, but on line 349, context.clip. So what I've done is drawn the grid and made the grid a clipping mask. And then I set a global composite operation to lighter and a global alpha to 0.7. And then I draw that image back onto itself twice on top of that grid mask. So it only lightens the areas where the grid was clipped and not the rest of the image. And that's how I achieve that effect of overlaying the grid on top of the image. Another way that I use Canvas is I take the big image that you've uploaded and I slice it up. And I didn't want to do a bunch of JavaScript on the server necessarily for that, although there are ways to do that in Node. You can use a Canvas emulator on Node, and I could have done it there. But I've got Canvas inside of the browser. You've already uploaded it locally into the browser, so why not go ahead and do all the slicing inside of the browser? So that's what I do. You can see here that these are the tiles once you're starting to play the game. These are the tiles of the image already sliced up. But these are all image elements. They're not individual Canvas elements. So how do I get all the individual data URIs for those? And unsurprisingly, I just use draw image. I loop through and grab all those tiles one at a time from the original Canvas into image elements. So it's pretty straightforward and gives you a lot of power, and then I push it right back in, creating image elements using the toData URL. As I said, you do a lot of trading back and forth, at least in my coding patterns. Okay, so that's kind of an introduction to some of the maybe more basic stuff that HTML5 JavaScript gives us. Now we're really going to get addicted to some hardcore stuff. This is the part that I really have the most fun with. So we're going to take a look at drag and drop. That's native drag and drop. Of course, you can always still emulate, and sometimes you do have to. We've got local file access. That's reading local files. We've got XHR2, which is a whole bunch of extensions. The one we'll talk about is actually being able to upload the file contents directly using an AJAX request. WebSockets using Socket.io, and then web workers. So native drag and drop allows you to take an element and say, this element is draggable, and I want you to be able to drag it around the page. That's not particularly interesting, and we've had that for a decade. What's really interesting, and we haven't had for a long time, we haven't had until just recently, is the ability to drag an image off of your desktop directly into a web application, and that's what I'm showing here. I've got an element on the page that I basically make a drop zone. I say it's okay in this drop zone for you to drop elements, and then I can drag it directly off of the browser, off of the desktop onto my browser and drop it there. You can see, and when you play around this, you'll see that I can actually, that thing only turns green when you are dropping an image file, and so I'm able to tell what kind of file it is you're about to drop and only allow image files and things like that. You can even check the image size to make sure it's not too big. Other things like that. So you can get a whole lot of functionality that would have been basically impossible in web apps. You would have had to use Java applets or other things like that. This is built into the browser, and it's only a few lines of code. So we'll just briefly look at that. So here I've got file drop zone, line 884. File drop zone, I listen for some events. I'm using jQuery just because it's helpful to not have to deal with all the cross-browser crap. Although when you're dealing with HTML5 browsers, there isn't a lot of that. But it's helpful to smooth out some of the event handling and AJAX and other things. But by no means is this jQuery only. But I'm listening for a couple events. Drag over and drag enter. That's the drop zone that it can respond to when I drag over it. I then ask, is this a file of the type that I want to accept? And I go ahead and change it to be a green box with a dotted line around it. Drag leave when it leaves. Unsurprisingly, we go ahead and take the green off. And then drop is the important one. We want to listen for that event. And when you drop a file element onto the drop zone, you're going to get a file reference, just like if you'd done a normal file upload, an input type selector, type equals file, and picked a file there, you're going to get that same file reference of what you've dropped in. So the way I tell it that it's okay the way I tell the browser that it's okay for you to drop some elements is we set the data transfer drop effect, and there's several values. Copy is probably the most common one that you'll use. Or you set it to none when it's not okay. So here I'm saying, is it a file drag event? If you're dragging something that's not a file, I don't want to respond to it. I don't even want to have to special case the code, so I just don't let you drop it unless it's actually a file. And then we have here, when you drop file accept in my code, when drop file accept is called, you see I have original event data transfer.files there on line 770. That's an array of all the files that I was dragging from my desktop into the browser application. I'm going to pass those along to a function, and we'll see here in a moment what we do with the references to that file. But you can see that it was actually just a couple of lines of code to make this native drag and drop enabled. There literally was no other magic involved at all. So now let's talk about what do we do when we want to get access to files. You may grab a file through a standard input box, or you may grab a file that somebody has drag and drop. But in either case, you're going to get a file reference. Now, what do we want to do with it? We want to read the contents of that file. This was impossible until recently. We now have the ability first to look at the file reference and get other information that we couldn't get before. In this case, I'm looking at its MIME type, so I can make sure that it's an image that I want to accept. If you're dropping in an image that couldn't be embeddable in a web browser, that's not helpful, so I limit it to PNG, GIF, and JPEG. Also, I can look at its file size and make sure you're not trying to upload some, 12,000 megabyte, super HDR photo to me and crash my server. And here's the important part, file reader. This is a new API that's in several browsers. It's not in Safari 5.1. I hear that it's coming in newer versions of Safari, but it's in Chrome and Firefox. This allows you to instantiate a reader object and read the image and read that file and get the data URL from it. Why do we want the data URL? Obviously, because we'll stick it directly into an image element, and then we'll start messing with it with Canvas. So I have this file reader. I have the onload listener that, because obviously it's an asynchronous event, I listen for the onload, and then I go ahead and call the preview. Now, what's interesting about this code is that, you'll see here in just a moment, I don't have to change anything about this code. When I call preview, I'm calling it if I've gotten it from a drag and drop, or if I've gotten it from an input file selector. It's the same type of file reference. I can get all the same properties and read it in exactly the same way. Local files in XHR2, if the user does not have a file reader, if they're in a browser that has a lot of these capabilities, but say they're in Safari 5.1 or some of the Safari mobiles that don't have a file reader, you want to provide some sort of workaround for them. And the workaround is that you can send that file using AJAX and then get the image back. So in this case, the only important line that's different from anything you've ever seen before is that when I send the file there on line 547, it's actually sending the file's binary data up to a server. And I have nothing more interesting than a PHP file that simply takes binary data and spits back out a data URL. So I have a data URL either from my server or from the file reader API, but in both cases, once I have that data URL, I can do all those Canvas things we just talked about. File reader is incredibly powerful, and it's the first step in a whole new set of things we're going to be able to do with local files. Chrome is experimenting with local file systems, literally being able to create a virtual file system directly on the system, on the user system, and manage files and folders and all kinds of things like that, sandboxed away from any of the rest of their stuff, so it's secure, but you really get a full, powerful API through some of these things. So local files are really getting cool in HTML5 JavaScript. So, are we getting addicted yet? I hope you guys are getting interested in some of this really cool stuff. And what I also hope you're seeing is that it's not that hard to weave these things together into a single application. It doesn't have to be some of the stupid toy examples we see out on the web. There's a plausible story for putting all these things into a powerful web application. Not that my game is powerful, but there's a way to do this kind of stuff. So let's talk about WebSockets. WebSockets are what I'm using to keep the browser constantly communicating with the server. It's a two-way communication street instead of having to do long polling or other things like that. Now, I use Socket.io. There's a number of other WebSocket emulation libraries out there. Socket.io is my favorite. It has a whole bunch of fallback things, for older browsers, even IE and Flash and all kinds of crazy stuff. So it basically can give you the same API, and you can have that sort of emulated layer in the older browsers and direct WebSocket connections in the newer browsers, but keep your web application constantly connected. That will allow your server to update things that the browser has not asked for yet. So it's a two-way communication channel, sort of that push notification, if you will. So I'm using it here just to, once I've logged in, I've established a connection between them, and each time you refresh a page, I just reestablish that same connection, again, using the session storage, stored session ID. So let's take a look at what the API for Socket.io looks like using here. The first thing is I make a very simple connection. I'm connecting to my server, and I'm using a namespace that I call site. I actually have two connections of WebSockets that I make in this app, and I'll explain that in a little bit why. But the first one is site, and the other one is called WW, which I'll explain in just a sec. But it's very easy to use this namespacing right on the end of the URL, and Socket.io will keep all that communication separate in those namespaces. We listen for events using socket.on. In this case, socket.on, I'm listening for the disconnect event. So if I'm somehow disconnected from the server, I want to make sure I listen for that. And then we send events using emit. So socket.on to listen for events, socket.emit to send events. This is a two-way back and forth. The really cool part, we'll see in just a slide or two, the really cool part is that's almost exactly the same code you write on the server, because the API is the same if you're using it, of course, inside of something like Node.js. Socket.io also has Python bindings and PHP and some other Java, I think, and some other things like that. But path of least resistance for me, obviously, was JavaScript in both places using Node.js. Here's what it looks like on the server. Unsurprisingly, socket.emit when I want to send. We do have some additional functionalities. I can select a particular namespace using the .of. And then .in is actually selecting a channel within inside of that namespace. So in this case, I want to restrict the communication that's going out for an individual game only to the people that are actually playing that game, as opposed to people playing another game. So I can really get fine-grained in terms of how much data is going out and not sending out too much data, not just broadcasting every message to every single connected user. And finally, we'll talk a bit about web workers. How many of you guys know what web workers are? Let me see how much I need to explain. Okay. A fair amount of you don't know what web workers are, so we'll just dive in. I don't want to just show you code and not explain what that means. Web workers are a new thing that's come in some of the latest generations of browsers. We are even starting to see it a little bit on mobile. Basically, it's a way to solve a problem that JavaScript has. Well, some people call it a problem. JavaScript is single-threaded. What that means is that when the browser is going to update the page, say you've moved an element or you've changed some CSS, or you've added some text or something, when it's going to update and repaint the page, it's using the same thread of your processor on your machine as the JavaScript execution, which in some cases is not a problem, but in some cases, if you're doing an animation and you're doing some heavy computation or you're receiving an event from a server, for instance, you can cause that stuttering. Another reason why you see stuttering is the garbage collection that happens. So you stuff all of your code execution, your CSS updating, your markup parsing, all of that stuff. It all happens on one thread on the user's machine. And in some cases, you can end up competing for things, and you start to see that stuttering that happens with animations and so forth. So a solution to this is to instantiate some JavaScript to run in an entirely different thread. And prior to web workers, we had no concept of how to do that, because JavaScript as a language has no concept of threads built into it. And so we needed something sort of an additional help, and web workers are that answer. The browsers allow us to point at another file, another JavaScript file on the server, and say, I want you to load up that code, I want you to run that in a separate thread, and that way, if it's running sort of in that thread, and the browser's doing some updates over here, this thing could be long running and blocking and all that, and the browser is still very smooth, and you can scroll around. You get none of that jumpiness. So if you're doing a whole bunch of communications, say for instance in a game, where I've got a whole bunch of data coming back and forth over Socket.io, and I also want when the user's moving a piece around, I want for that to be as smooth and graceful as possible. One solution to that is to put those in separate threads. Web worker for the Socket game communication, and then the main browser thread for making things smooth while I'm dragging pieces around. So web workers allow you to instantiate an asynchronous set of running JavaScript code sort of in its own sandbox, and then communicate with it. And the cool part is you communicate with it very much like you communicate with WebSockets. It's just a remote piece of code that's running. It happens to be on the same machine and not on a server across the internet, but you're still posting a message to it and listening for messages back, and the worker can do the same. The worker does not have access to the DOM or any of those other things. It's really in its own sandbox, but it can send data back and forth, and you can communicate that way. So we'll take a look at what that code looks like. Here we instantiate a new worker. I give it a file, www.js. And let me go back. You listen for messages using gameworker.onMessage. And you parse out those messages in the same way that you would parse out messages from Socket.io, for instance. And you send messages using postMessage. So this is what's happening inside of my main page. I've got my main page going, and I'm saying, I want you to start up a web worker for me and run that code over there in that web worker. I want to listen for when he wants to tell me things, and I want to send him stuff. Namely, I want to send him a go ahead and get started message. So that's what this line 399 does, says go ahead and send him a start message. It tells him what the game ID is and that he can get started and make his communication. Inside of the web worker, inside of www.js, we've got a couple things that are new to us. First is that we're able to synchronously import other scripts, so it doesn't have to all be in one file. In this case, I'm importing the Socket.io client library. It can run inside of a web worker. That allows me to establish a whole different thread of WebSocket communication that's unblocked from the main browser's thread. Down here at the bottom on line 23, we're posting messages. That's posting messages back to the main page. And we're listening for messages using onMessage. It's pretty straightforward and simple. Now, again, there are polyfills and wrappers that make these APIs even nicer, but I actually wanted to show you the underlying API to show you it's not that complicated, actually. It's very simple to listen, send, and receive messages back and forth, and your code looks the same, so you don't do a lot of mental context switching. Code looks the same in both those cases, very similar to when you're writing WebSocket code. Last piece of code I'll show is, in my particular game, I wanted to have a fallback for some of the browsers which may have advanced HTML5 functionality and capable of playing the game, but they don't yet have web workers. This would be some of your, a couple of generation old mobile devices that have a lot of things like Canvas and stuff, but they don't yet have web workers. So this is a shim for not having that worker API. It does not actually create asynchronous multi-threaded JavaScript, but it simulates it using the same API. So my code doesn't have to worry about it. And in those cases, those browsers would still work the same, but maybe have slightly less performance in those few cases where there are conflicts. But the API is the same. So I create a worker API that you can instantiate, and I have postMessage and onMessage, as you would expect. Yeah, so the question is, do I have an overview of the things that are upcoming in HTML5? Yes. So I'm actually, I just started up a book project called Beyond HTML5, where we're going to write about things, some of that cool stuff. A number of things that are coming up that are on the horizon. We talked about the virtual file system that you can read and write files. There's web intents, a very cool thing. If you're familiar with Android, you know about intents. But web intents allows your web application to register with the browser and say, anytime somebody wants to do XYZ action, give them the option to invoke my web application even if they don't have me loaded yet. So say you're a photo editing service. You've got a person that logs into their site, and it prompts them and says, hey, this photo application would like to register a web intent that it can handle any kind of photo editing that a user may run across, when they find a photo on Flickr or something like that. So then they say, yes, that's okay, and then they're on Flickr and they click something, to do something with an image. The browser pops up and says, hey, would you like to invoke that photo editing application that you authorized? So web intents are a very cool way for web applications to kind of interact with each other, sort of, it's distributed mashups, if you will, allowing each person's web application to handle different things. Shadow DOM is another really cool thing that's coming along. It's just been kind of proposed and it's working its way through. The browser has had Shadow DOM for a long time, and what that means is when I have an element like input type equals file, there's actually more elements there underneath that the browser doesn't tell us about. There's a button element and some other things like that. Calendar is another example. When you do input type equals calendar, it renders a whole bunch of DOM elements to show you that calendar pop-up widget, but you have no access to any of that Shadow DOM using normal current technologies. The Shadow DOM sort of proposals that are coming along are going to allow you to be able to access some of that stuff in some interesting ways, targeting it with CSS and things like that. But you're also going to be able to create your own tag types with your own Shadow DOM. So you can push up a tag type that when it sees that in the markup, it knows that this is the DOM you want it to build, and this is all the JavaScript code that you want to associate with that element. And then inside of your markup, you can simply say, tag foobar, and it invokes the foobar.js and creates that Shadow DOM, and it works exactly like native elements do. So it's giving us that very cool functionality that we have to go and create all those elements ourselves, and then we have to make sure, we have to be very careful that through CSS targeting that other things on the page don't affect that. This allows us to create that sandbox with Shadow DOM. Some other things, peer-to-peer. WebRTC is an API that's coming along in a couple of the browsers right now. Chrome, definitely has. I think Firefox is getting it as well. WebRTC is going to allow a direct connection between your browser and my browser without a federated connection to a server. So we'll be able to do peer-to-peer, video chats and things like that. Games like this, the communication between us could go directly without going through a server. So there's a bunch of really, really cool stuff that's happening. And I would say this, it's not particularly useful to try to put labels on things and say, well, that's HTML5 and that's HTML6. That's a stupid label. That's just marketing buzzwords. I think HTML5 signals this whole new open acceleration of every possible technology in the web platform. It's open, that we all know what's happening. We can all participate in it. So I think HTML5 and Friends is the term to use going forward to talk about all these things. But there's definitely a lot of very cool stuff that we don't even fully know how it's going to work yet, but we know it's coming. We know these browser vendors and specifications are really trying to experiment. And that doesn't even scratch the surface of the cool stuff that they're thinking about for CSS4. Some really amazing stuff there. So there's a bright future. Even the cool stuff that we talked about today, which is kind of more fully baked, and you can actually build applications on it. It'd be hard to build an application entirely around something like web intents yet, because it's only in a very experimental version of Chrome. But as an example, the social sharing company AddThis, I don't know if any of you guys saw, but they just released an update to their service that uses web intents for browsers that have it. So now when you are on a site, you don't even have to click and add this button. It'll just say, would you like to go ahead and share this with Facebook? Because it can register that for you. So there's some very cool stuff that's happening. The web applications that we know today are going to be entirely unlike what we see even a year or two from now. So good question. So just any other questions? My final question to you guys. I do want you to ping me if you have any questions. Find me online or on Twitter, things like that. But I do hope that you will go away from this believing that HTML5 and JavaScript is something you practically can use right now. Thanks for having me. I appreciate it very much.